All right, so today's lesson, the essential question, what makes a polygon? What are the names to classify polygons? Let's go to the definition of polygon. A polygon is a figure formed by 3 or more segments. When we talk about sides, we're going to talk about the segments of a polygon. So you're going to hear me say sides, I'm talking about the segments of the polygon. When you hear vertex or corner, I think I might say corner a little bit more in this class, but vertex is also the name. Endpoint where sides of the polygon intersect. And then a diagonal is a segment that joins what we call non-consecutive vertices. A diagonal is some sort of segment that goes through a polygon and its endpoints are like 2 corners. So going from a corner to another corner across the room or across the polygon. So looking at this figure, we're going to highlight some things. So in blue, side PQ, you're either going to hear me say side PQ or segment PQ. I could have chosen any of those corners to be a vertex. P is a vertex, Q is a vertex, any sort of corner. And then a diagonal. So yeah, diagonal QT. I could have done QS, I could have done PR, PS, I could have done TR. There's several options for diagonal. In order for a figure to be a polygon, it must have the following requirements. You've got to have all sides of the polygon have to be, oh wait a second, hold on. Each side must intersect only one other side at their vertex. Ooh, wait a second. At their, not vertex, it's actually their endpoint. Lo siento on that one. So is the figure a polygon? And then we're going to say yay or nay and why. So yeah, all sides are straight and sides meet at their endpoints. And then number 2 is a no. So in this next one, no, the endpoints don't meet at the, or no, the endpoints don't meet. There we go. And then this next one, so on here I realize it's not, I don't know, this corner didn't look so well. It was supposed to be a polygon. It's supposed to be a polygon because they can be caving in and it's supposed to be all closed. So I wanted this one to be a yes. These are the common ways to classify polygons. The one we may not be familiar with is a heptagon, which sort of create our arrows. So like this arrow actually has 7 sides to it. All right, but these are the not so common. So here's the point. Tell how many sides it has. Figure out the type. State 2 ways to name the polygon because we don't know how to name bigger polygons than triangles. And we're going to name the diagonals that have a vertex of C or that have an endpoint of C. And then state 2 ways to name the polygon. You start with any letter, and you could either move clockwise or counterclockwise around the figure. So let's say I do start with A. I have the option to say A, B, C, D, E, F, or if I start again at A, I could go the other way, A, F, E, D, C, B. If we name all the diagonals that have a vertex C as an endpoint, then I'm going to start with C and give me a diagonal with C. So CA, CE, CF, those are all the diagonals with C, and we write it as segment CA, segment CE, segment CF. So yes, this is a polygon. It's 4 sides, so we look at our chart and it's a quadrilateral. So in the next one, is it a polygon? This is not, because of curves. So yes, in this next one, it's got 5 sides, so we're going to call it a pentagon. In the next one, however, it's not a polygon. It's not a polygon because these 2 sides, it goes with the second property. What was that second property? That not just the sides meet Yeah, the sides intersect one time, and it's got to be at the end point. Notice how this side intersects at 3 different places. Every side should only be intersecting at 2 spots, the endpoints. Can you do that on the test? Sure. We know the measure inside a triangle is 180. If we create a diagonal, so with me, use a straight edge and create a diagonal corner to corner. The triangle on top has a total of 180 degrees inside, and the triangle on the bottom also has a total of 180 degrees on inside. So what's the total inside a quadrilateral? 360. So the sum of the interior angles of a quadrilateral has to be 360. So now I'll be able to find missing angles inside. If I figure out how much do I see already in each corner, add those up, take it away from 360 now. Let's practice this one. So first, we add those 3 together, take that away from 360, and we get 110. All right. So because the directions say, find the measure of angle A, how I can represent my answer is, measure of angle A equals 110.